I forgot to do this. Dang it. I think it still works. I don't know why that doesn't work when I do it here. Oh, yeah, it rolls. Okay, so here we go. We talked before we started chapter 8 about statistical inferences, and there's two big ones. Confidence intervals are one of them. And now we're going to do test of significance. So big picture, what a test of significance is, just a big picture real quick. 9.1, we're going to talk about them and explain them and see what they're doing. And then 9.2, we're going to actually do them just like we did in chapter 8. So 9.2 is one sample, and 9.3, I'm sorry, is two sample. Okay with all that? And then we get to chapter 11, and there's only two sections because we don't have to introduce them. So we're doing proportions, and then we'll do means. Okay, but big picture what this is. There's some claim out there in the world about something. Coca-Cola claims there's 12 ounces in a can. So many ounces in a bag of chips. 40% of all the cars are white. That one's made up. Okay, but there's some claim about something all over the place, right? We know that we're going to get 32 miles per gallon in a car. It's just some claim. We don't know for sure if it's true or not. So when we start doubting a claim, that's what a test of significance is. That's what it is. And so the only way we're going to doubt that is we're going to get a sample. We're going to get a sample of data, right? And we have learned throughout the course of this year, we know that that sample will not be the same as that claim. Or it might be, but if it is, we sure can't dispute it, right? But more than likely, it won't be the same. So is that sample that we get something we expect to get, or something that's really significant? Like it's really far away from that claim, like more than 2 standard deviations. Okay, so we know what sampling distributions are. We know how they act. We know what the population claim is, and we know how it should deviate around that population, depending on what our sample size is. As our sample size increases, we know it deviates less, right? We have all that stuff kind of going on. So we're going to get a sample and compare it to that sampling distribution. And we kind of did that in chapter 7 already a little bit. And so what you're going to basically do is see how many standard deviations that sample is away from the mean. And if it's more than 2 standard deviations away, we can dispute that claim. We can dispute it. And if we aren't, we can't dispute it. We have to basically believe that their claim is true. Kind of okay? Big picture. It's a lot more involved in that, but that's basically that's the gist of what a significance test is. Yay? So big picture, let's break it down. So we're going to big picture, little picture, and then we'll go back to big picture. Yay? Confidence intervals are the 2 most common methods of statistical inference. We use confidence intervals when we don't know what the population average is, right? So that's why we use confidence intervals. That's completely different than what we're going to be doing this chapter. We're using confidence interval to estimate what the population average is. Now they're going to tell us what the population average is. We're going to do a significance test to dispute it, or I don't want to say validate it, but dispute it or not. So it's called a test of significance. We're going to use evidence, and our evidence is a sample. We're going to use evidence against that claim of that population. Okay? A particular school claims that 73% of the students have a GPA of 3.5 or higher. That's what their claim is. So we have to believe that's true. So right now, you guys should know, oh my gosh, oh, there they are. I gotta quit putting these things wherever I want to. Right now, that's what our claim is. P equals 0.73 because P is the population average, right? So it's going to, this chapter, if you will, You're going to see some p hats, and you're going to see some p's, and you're going to see some x bars, and you're going to see some mu's. And it's going to be really important that you guys distinguish of what the heck we're talking about. Last chapter, we didn't have a whole lot of population stuff. We had a whole lot of sample stuff because we didn't know what the population stuff was. Now they're telling us what it is. Now, whether we believe it or not, we don't know, but that's what they're telling us, okay? The State Department thinks that they're removing certain students to get this percentage. In other words, they think it's too high. So the claim is that. The claim is P equals 0.73. And after that claim, we have to get a sample to test that claim. Do we expect to get 0.73 on our sample? Probably not. So our question is going to be, how far away from that 0.73 are we? That's big picture of what we're going to do. Is that sample something, the statistic, right, the sample, is that something I expect to happen, or is it something that's unlikely to happen? Is it within 2 standard deviations, or is it outside of 2 standard deviations? Click. So that's what a significance test is, a hypothesis test. You'll hear me call them both. You'll hear me call them significance test. You'll hear me call them hypothesis test. It's a test of significance, hypothesis test, all that, okay? It's a procedure that uses a sample to decide if a claim is false. We're going to use a sample to decide if that claim is false. Notice it doesn't say if it's true, if it's false, okay? We're going to use a sample to decide on if that claim is false. If it's false. We can't decide if it's true. That comes out throughout the lesson. All we can do is basically say it's false. Or we can say it's not false. But we can't say it's true. Okay? Using a sample to decide if a claim is of the population is false. Right? Note, we don't ever say it's true. We do not say it's true. All we can do is say it's false, or we can say it's not false. Okay? Beautiful. Click, click. There are 2 parts of a hypothesis. So a hypothesis is something we have to do in this claim. Y'all know a hypothesis is like an educated guess or something, right? I think that's the science definition of it. Ours is just a little bit different, what we're going to do in this, right? Chloe, did I go too fast on something? Or? Okay, you're good. 2 parts of a hypothesis. So the first part of the hypothesis we're going to call is the null hypothesis. The null. H sub naught. H sub 0. Y'all know mathematicians are lazy, right? We don't like to write null hypotheses every single time, so we'll abbreviate it. H sub naught. Yes, I will call it the hoe. I will. I'm calling that the hoe. I am never calling a student a hoe. Never. That's what I'm talking about. That's what you're talking about. Okay, get that straight. I will never. The hoe. H sub naught if you don't want to say the hoe. It's more fun to say the hoe, though. Don't go home and tell your mom and dad, though, you talked about hoes in class. Don't. That's the claim. That's what we're assuming to be true. That is a claim. That's the assumption. That 73%, that's my null hypothesis. So the way we are going to write this stuff is we're going to say hoe. Now we're not going to say equals. You're going to do hoe and then like a semicolon. Semicolon. Or is that semi or is that the colon? Either way, I don't care what you do. Don't put equals. Don't put equals. After that part, now we're putting the parameter. It's going to be P or it's going to be mu. It's going to be one of those two. If it's means, it's mu. If it's proportions, it's p. And that's what you put equals. That's what you put equals. That's an uh-oh that some students do. They get in such a hurry. They'll say ho equals. No, ho doesn't equal anything. The ho is. Okay? So it's just a habit. I don't say a habit. It's an uh-oh that some students will make because, again, it has nothing to do with you guys but getting into a hurry. We have to have a parameter. Ho is not a parameter. We have to have a parameter. Okay? And it has to be a parameter. It cannot be a sample. It's always a parameter. So I will promise you on multiple choices, you're going to see ho and you're going to see a p hat and you're going to see an x bar. Those are wrong. Those are wrong always. They're never, ever, ever right. It has to be a parameter and it has to have the equal sign. It has to have those two things. Okay? It's not a big deal. Most students don't have an issue with that. The issue is sometimes they use the wrong parameter, which I can't imagine how you can possibly use the wrong parameter. They'll use samples instead of parameters, and sometimes they won't use the equal sign. Now, it can be a less than or equal to or a greater than or equal to, but it's got to have the equal sign. It's got to have the equal sign. I don't ever write a less than or greater than equal to, but it can have that, but it's got to have the equals part. It's got to have the equals part. Any question about the ho or the null? Ho, Santa Claus, he just came. He had 3 nulls. No boats. That's trig. Denoted as H sub O, normally explained with symbols. So I use a colon, but some students use a comma. You can use whatever. I just don't like to see ho equals 0.79. That's you got to have the parameter in there. You got to have a parameter. And again, it's a parameter, not a sample. Parameter. Always about populations, never samples. You're going to hear me say it until I'm blue. This chapter, let me rephrase that. 9.2 and 9.3 is just going to be p's because we're just dealing with proportions. 9.1 might have some mu's in it. 9.1 might have some mu's in it because they're just getting you guys to think about, is it categorical or is it numerical? And it's not a trick. It's not like you guys are going to have to dig in depth about it. You're going to know what it's going to be. You're going to know what it's going to be. All right, okay? Always has the equal sign. It's always a population. It could have a greater than or equal to or less than or equal to, but it has to have the equals part. It has to have the equals part. Okay, pencils. One more. I don't know why I put that here. It doesn't. Whatever that parameter is, has to be defined in context. So if I said P equals 0.73, then I have to say where P is the true proportion of students with a 3.5 or higher. Where mu is a true average gas mileage of a GMC pickup truck. Okay? So you have to define it in context. You have to. You don't have to do it right after the ho. You don't have to do it before the ho. You have to do it in the problem somewhere. This will make a little bit more sense on, tomorrow. Good gosh, we got back-to-back days. Okay, everybody okay with the ho? The null, the first part. The second part is called the alternative hypotheses. It's the alternative, and we're going to abbreviate it as H sub A. The ha. So we have a ho and we have a ha. Ho and a ha. We can do a lot of ha in here. I try to, but you guys don't think I'm very funny sometimes. Somebody just did. Thanks. Okay. That's what we believe, or that's what we're trying to prove. Or it's what they believe, or whatever it might be. But that's what we're trying to prove. We think it's less than, we think it's greater than. We think they're lying. We think they're underfilling. So we think it's less than. Okay? So whatever your hoe is, if that's P equals, then your ha will be P. And whatever number this is, this number has to be the same. You can't change numbers. This can't be 0.73 and we think it's less than 0.72. You can't do that. Your test is going against their claim. So we think it's less than 0.73, or we think it's greater than 0.73, or we might even think it's different than 0.73. It's one of those three. It's one of those three. This one has to have an equal sign. This one could have a less than, it could have a greater than, or it could have a not equals to. It won't have three of them. It won't have one of them. It can't have the equal sign. It still has to be a parameter. If this is mu, this is mu. This is p, this is p. Whatever number this is, this number has to be the same. And I'm telling you guys, when there's a multiple choice question that defines, it will say, what are the hypotheses for this? You're going to have 5 choices, and 3 of them are going to be wrong before you even read the question. 3 of them are wrong before you even read the question, because they're going to have hats, they're going to have bars, they're going to have different numbers, they're going to put a greater than or less than here and put the equals down here. 3 of them are going to be wrong without you even looking at them. Y'all follow what I'm saying, right? The only choice you're going to have is one of these is going to be, this is going to be equals, then one of these is going to be a less than, and one is going to be a greater than. And that's one that has to be. So it's kind of nice with the multiple choice. Yes, ma'am. Has to be the same. And that's another one. Yes, sometimes they may switch those numbers, but it always has to be the same number. That is correct. You have to, because you can't, again, I don't know what the sampling distribution of 72 looks like. I know what 73s look like. I don't know what 72s looks like. So I can't prove it's less than 72. I mean, if it's less than 72, it's going to be less than 73. So it has to be the same number. Okay? Y'all okay with that? Hoes and ha's. Hoes and ha's. Hoes and ha's. Less than, not equal to. We said all that stuff. Let me stop and just to make sure. Y'all okay? Any questions about the hoes and ha's? Guys, the hypotheses is worth its own E, P, or I. The hypotheses gets its own E, P, or I. So in my test, that's 4 points. So you get a point for the hoe, you get a point for the ha, you get a point to define the parameter. And then you get a point because I make everything 4 points. Because if you forget something or you get something wrong, I don't think that's, 66% of it. I think 75% of it. If that kind of makes sense. So that's kind of why I make it 4 points as opposed to 3 points. You good? Certain Bentonville Tiger says that a long run proportion of made free throws is 80% or 0.8. We suspect the player is exaggerating. State the null and the alternative hypotheses. P, proportion. P equals 0.8. Again, some students will mess this up and they'll put hoe equals. Don't. You have to have a parameter. You have to have a parameter, okay? And then we think they're exaggerating, so we're trying to prove that it's less than 0.8. And then you got to tell me what P is. Where P is the true proportion of made free throws by this Bentonville Tiger, yada, 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 whatever you got to do. They're looking for that. Make sure it references the population. Make sure it references the population. Question. This is not a hard topic. Though where you're gonna mess up is if you don't put it. I mean, really, very few students mess up by not putting an equal sign. Very few students mess up by going the wrong way. Very few students use samples. They don't use populations. Okay. Very few students forget to define it. Because if you do one of them, chances are you're going to get all three of them in there. Good enough with all that stuff, right? And it's not going to be this is not going to be hard to figure out. We either think they're over or underestimating, or we think it's different. And it's not a trick. And then you're going to know it's proportions or means. Good enough? One more example. Oh, there it is. Non-hieroglyphics, where P is the true proportion of free throws made by this particular pair. A manufacturer of M&Ms, the manufacturer of M&Ms, claims 40% of plain M&Ms are brown. A sample of M&Ms will be used to determine if the proportion of brown M&Ms is different. Ho. Point 0.4. Ha. Not 0.4. We think it's either higher than 0.4 or lower than 0.4, or we just don't think it's 0.4. And then we got to say, P is the true proportion of brown M&Ms, brown plain M&Ms. Yes, no, maybe, happy, happy. Write down what you need to. We're getting a lot of snow or a little bit of snow? Y'all hear, what are y'all hearing? I'm hearing a little of everything, right? The only job in the world you can be wrong and still have a job. If I graded your test like the weatherman guesses what we're going to do, I guess we're getting it though. I don't think there's any doubt it's coming. And it's going to be cold. And if it stays that cold, who knows what's going to happen, because that stuff's not coming up. No, not yet. Probably in a little bit. Don't forget it though. Pencil's good? Everybody happy? Click. Click, click. Okay. One-sided tests. They'll use this as terminology. They won't ask you this a lot of times. Is this a one-sided test or a two-sided test, right? One-sided test is when you have a less than or a greater than. You're testing one side. You're testing one side. I mean, this is not a secret. You're going to have a normal distribution. You're going to have a normal distribution. And they're going to be, the claim is going to be right in the middle. Because that's what the claim is. Because of sampling distributions, we know that mu of x bar is equal to mu, or mu of p hat is equal to p. So we have some claim about some population that will be right in the middle. And we're going to get an x bar above or below it. Or we're going to get a p hat above or below it. If it's a right-tailed test, ha has to be greater than. Because we're talking about over there, that's the tail. So one-sided test, it could be a one-tailed test. Either way, it could be a right-tailed test or a left one-tailed test. It's left-tailed if it's less than. It's right-tailed if it's greater than. It might be one-tailed. It might be one-sided. There's different things that they can call that. And each book calls it something different, and AP might call it something different each time. Okay, with all that stuff, right? So anytime you see a less than or you see a greater than, it's a one-tailed test. If it's greater than, it's a right-tailed. If it's less than, it's a left-tailed. When the alternative is greater than or less than, that's a one-tailed test or a one-sided test or a right-tailed or a left-tailed. When the alternative is a greater than or less than. Okay? And again, it's just terminology. I don't think I recall AP asking you, is this a one-tailed test or a two-tailed test? Maybe they do. I don't think so. I don't recall it. But at least you know what the terminology means, right? And that's two-sided means it's a two-tailed test or it's a not equals to. We're not testing one side, we're testing both sides on a two-tailed test. Two-sided test, two-tailed test, all that stuff is the same. Okay? Again, just some terminology that you got to make sure you're familiar with. Beautiful. You guys did pretty good on your test. I was pretty proud of you guys. One question that got a lot of you cats, though. The very last free response question, where it said, is it acceptable to do the difference between the two proportions? Okay, remember that? And a bunch of you guys said yes. And one of the conditions to do a two, or to do the difference between two, is you got to have two independent random samples. And we only had one. So we can't do the difference between those proportions. Fair enough. Yes, sir. At some point. At some point. Y'all can look at them anytime. Anytime we got dead time or any flex, y'all can look at them anytime. Hopefully I'll have some time to class. Because again, a lot of stuff you're going to see again. Right? I'm not too concerned, but this, a lot of this you're going to see again. There was another question on there, one of the multiple choices. That's kind of my judgment on how guys are doing from year to year. It was the one with the margin of error. I don't know if you guys remember the margin of error of 0.08. So I did have a couple of you guys ask me about it, right? Because when you rounded it, it was like 0.08001. Am I supposed to round up? Am I supposed to round down? And that was kind of the whole gist of the answer. Because we used 0.5 and 0.5, and you guys, most of you you used 0.5 to get that 0.08. But hopefully you knew that 0.05, not 0.05, 0.5. 0.5 is the worst case scenario. So it can't be greater than 0.08. It has to be, it could be less than 0.08. Anyway, that's a highly missed question the past few years, and more kids got it right this year than any other. So that's kind of how I'm judging when I say that you guys are doing okay. The confidence intervals, for the most part, you guys knocked it out. The guys that don't pay attention and don't do what, didn't do the greatest. But for the most part, there was minus zero. That first page, there was a bunch of minus zeros on the first page. Bunch. The biggest issue on it was finding the level. That was the biggest issue. If we took many samples, the sample will contain, that was bad, that's bad words. The interval will contain, but we'll talk about that later. All right, here we go. I can't emphasize this enough. Make sure you define that p-value, or not p-value, I'm sorry. Define that p or define that mu. Define it in words. I'm going to give you some hints on tomorrow. I'm going to give you some hints tomorrow that will help you, so you won't mess this up, right? I'll kind of go with it right now, right? You have a ho, you have a ha, and then you have to tell me what the p or the mu is, right? Three things. Guess how many conditions there are? 3. Guess how many things make sure that you're in the conclusion? 3. So I'm going to I'm going to talk about the words of threes. And so each thing you do on this, if you do 3 things, you got them all. If that kind of makes sense. It will tomorrow, I hope. All right. We got a Hawaiian pineapple company. They're interested in the size of their pineapples grown in the company's fields. I can't imagine why they would be interested in that. Last year, the mean weight. Told you, they're not going to confuse you about proportions or means. The mean was 31 ounces. So I know for a fact I got that. Okay, I got that. Now, I don't know if I need that yet or not, or whatever it's going to be, but a different irrigation system was installed after the growing season. Managers wondered if this change will affect the mean weight of pineapples grown in the field this year. State the appropriate hypotheses for performing a significance test. Ho. Mu equals 31. There's no doubt that that's what that has to be. Ha. Mu, that has to be a 31. And now we're trying to decide if we think it's less than 31 ounces, or we think it's greater than 31 ounces, or do we think it's different than 31 ounces? And in this problem here, I think we're just trying to figure out if it's different. I don't know. It just says how it's affecting it. It didn't say if it's affecting it positively, negatively. It just, is it affecting it? Okay? Make sure we define mu. Mu is the true mean weight of pineapples in this field, yada, 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 whatever we're going to go with that. Okay? True mean. True mean. Any questions? Told you, I don't think this is hard. U equals 31. Mu does not, or true mean weight of pineapples grown in the field this year. Click. I can't emphasize this enough. Hypotheses always refer to a population. So if you ever see something like this, it's wrong. If you see something like this, it's wrong. It cannot be samples. It has to be the population. It has to be the population. Click. All right. Y'all, I told y'all we've had a crap ton of interpretations in this class. And if this one's probably not the most important one, I don't know what is. This one's important. This one, I mean, they're all important. They're all important. But this one's one that's going to keep you from getting a 3 or a C, right? The other ones keep you from getting 5s. You'll kind of follow what I'm saying, right? You can get by without knowing those and still get a 5 or still get an A. If you don't know this one, I don't know if I can say that. Fair enough? I mean, this one's important. So they're going to call it a p-value. P-value, all right? So let me just explain to you what this is. How I interpret it might be different than how you interpret it. It might be different than the book interprets it. And we've talked about several of these things. It doesn't matter as long as you get it all in there, right? So we have some claim about the population. It's going to be a normal distribution. We have some claim about that population. Let's use mu. Okay, some claim, right? And what we're going to do is we're going to get a sample. And we're going to get a sample that won't be mu. It's either going to be above it or below it. Hopefully it's above it if we're trying to prove it's greater than. Hopefully it's below it if we're trying to prove it's less than. Because if it's below it and I'm trying to prove it's greater than, it's impossible to prove that. Hear what I say, right? If I'm trying to prove it's less than and my sample's greater than, there's no way for me to prove it's less than. No way. And vice versa. If I'm trying to prove it's greater than and my sample's less than, it's impossible for me to prove it's a greater than. I mean, my sample better be on the side I'm trying to prove. And if it's not, I shouldn't even do a test because there's no way to prove it. Good enough? So I'm going to get an X bar somewhere away, right? And guess what we're going to end up doing? We're going to calculate how many standard deviations that is away. That's what we're going to do. So we're going to get a Z-score. Yeah? We'll get a Z-score. All this we're really doing tomorrow, but this going to speed up the process tomorrow. We're going to get some kind of Z-score because that's going to tell you how many standard deviations away it is. Well, in chapter 2 and chapter 7 and chapter, I don't know how many more times we've done it, we've changed those Z-scores into the probability. We've changed it into the probability. That's what the p-value is. That's what the p-value is. It's the probability, listen, probability of getting this, or I used a different word yesterday, or further, because I keep saying or greater, but it could be or less. So or further, because we always use this, right? We always do normal CDF from there to 99999, or normal CDF from negative 99999 to there. That's what the p-value is. It's the probability of getting our sample, or what we got, or what we observed, or what's given to us, or whatever, or greater, or less, or further, assuming Ho is true. And we have to state that part because we have to assume that's true. Because if that's not true, I don't want to say if that's not true, if I'm using something different, then that's a different probability. That's what that p-value is. Let me give it to you, textbook definition. I just did this right here, right? A player who claims to make 80% of his free throws only made 64. $64 looks like it's a whole lot less than 80. But we have to figure out how many standard deviations is away. Is this giving me some evidence they're lying? Yeah. Yeah. In fact, 64 is pretty far away from 80, but I don't know if it's far enough. We have to show that statistically. Okay? And we know what the standard deviation of this thing is because we did that in chapter 7. It's going to be 0.8 here, 0.2 here. Again, this is all tomorrow. And then we're going to do it over 50. So I know what the sampling distribution looks like. I know what I should expect to see, and I should know what I don't expect to see. And so after I do all these calculations, it's going to tell me, do I expect to see that 0.64 or do I not expect to see that 0.64? And if I don't expect to see it, I got to reject it. It's a lie. And if I expect to see it, I can't say it's a lie. Good enough? So that p-value is going to be the probability of getting 0.64 or less, assuming Ho is true. Assuming 0.8 is true. Good enough? Oh, wrong button. Click, 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 p-value. This is their definition, right? You guys have learned, I don't care how you say it, we just got to get it all in there. The probability, we got to have a probability. It is a percentage. It is a chance. I like the word chance better than probability because I can't spell probability. I can spell chance. Of getting the value observed. I don't use value observed. I use sample. Getting what is observed. Getting the sample as extreme or further. Right? Because it's not just getting that specific value, it's that value or everything to the right of it, or that value and everything to the left of it. And then we got to say when the Ho is true or when the null is true. And when it's somewhere in there, I'm sure we got to have what? Context. I'm sure we got to have context somewhere, somehow, some form, some fashion. Of all the interpretations, this is probably the one that's going to be said a bunch of different ways. Maybe the level is probably more than all the others. But this one, you just got to get those three things in there. Probability, what we see, further, Ho is true. I think that may be 4 things. Context, that's 5 things. Any questions about what that p-value is? We're going to talk about it, but there is no doubt that's going to be interpretation on your test. Interpret this p-value. That's what it's going to say. No doubt. No doubt it's on the AP test. No doubt it's on my test. No doubt it's going to be in the multiple choice. You're going to see it. So you kind of just need to understand what that is. And hopefully, maybe not today, but after tomorrow for sure, hopefully you really understand that p-value. It's the chances of getting what we got. Chances of getting the sample, assuming Ho is true. Or greater, or less. Yippee? Happy? We're going to calculate that tomorrow. Right now, I just want to make sure you understand what it is. It's a fine line. Sometimes I teach you how to do it, and then I teach you how to define it. This book tells you how to define it and shows you how to get it. So I don't know which way's better. Okay, hard for you guys to see this, but it's on your notes. Calcium is a vital nutrient for healthy bones and teeth. The NIH, National Institute of Health, recommends that the calcium intake of 1,300 milligrams. Recommends 1,300 milligrams. The NIH is concerned that the teenagers aren't getting enough. Is this true? Researchers decide to perform a test. So they gave you the Ho and they gave you the Ha. They'll do that a lot of times. They'll go ahead and give it to you. Okay, they'll give it to you. Where mu is the true mean daily calcium intake of the population. So they gave you Ho, they gave you Ha, and then they define mu. Mean. We're not dealing with proportions, we're dealing with means. Okay, that's good. They asked a random sample of 20 teens to record their food and drink consumption one day. I wish they would have done it a little bit more than one day. Take an average over them, but whatever. The researchers then compute the calcium intake for each student. Okay, so we have the scenario set up. We're good. No other information yet. Next thing it says, data analysis reveals that X bar is 1198. Uh-oh, it's not looking good. It's looking like the teenagers are not getting enough calcium. That's what it looks like, because I only got 1198. I'm supposed to get 1,300. Now I got to figure out the chances of getting this, assuming that's true. Because again, we're going to have a normal distribution, and this normal is going to put mu is at 1,300, and I got 1198 somewhere over here, and I want to figure out that. Normal CDF from negative 9999 to 1198 with that mean, and I don't know the standard deviation because they didn't give it to us. And again, that's really 3 chapters away. Good enough? Do we have some evidence? Yeah, I got some evidence. I'm wanting to know if I have statistical evidence. Got some, I need statistical. The p-value is 0.1404. Do I have statistical? No. Because that 0.14 is what? Bigger than, what's that number we've been using all year? 0.05. 0.14, I expect to see that 14% of the time. That's not surprising. So I can't dispute that claim. But they want me to interpret that p-value, right? There is about, squishy words, I love squishy words, right? About 14% chance of getting 1,300, sorry, about messed up there, 11 98, was it milligrams or milliliters or what was it? Milligrams or less. No, yeah. Or less, right? And the reason why it's less is because my ha was less. All right, that's why I'm going to say or less. Or less, that looks like of, or, because that's what I wrote. Or less, assuming ho is true. Assuming 1,300 milligrams is true. I don't know how much context I need to put on that. Okay with all that stuff? Again, that's my definition. Yours might be different than that. I guarantee it when I hit next, it's going to be different than what mine is. Assuming the mean intake in the teen population is 1,300. There's a 14% probability of getting a sample mean of 1198 or less by chance alone. Good enough with all that stuff? You can use symbols, you can use whatever you got to use, but we got to get it all in there. Talking about how we have to assume ho's true and the chances of getting this number or less. And again, you guys knowing what we already do know, that's not statistical evidence. I can't prove that the teens are not getting enough. Because I expect to see that 14% chance. That's a pretty good chance of seeing it. I know it's not great. 14% of you driving to school and breaking your arm, having a wreck, pretty high. Out of 100 days, you're going to have 14 of them? No, I'm not doing it. Okay, everybody good? Happy? Again, big picture type things. I like to put things in perspective of reality, right? I got a judge right here. You guys have seen a lot of, I'm sure, maybe you haven't, I don't know. There's a lot of court stuff on TV, a lot of drama TV that deals with the courtroom, right? Suits, that kind of stuff, right? You got a guy on defendant, a guy, girl, whatever, right? Criminal. Well, I shouldn't say criminal. Person's on trial. How about that, right? What do we have to assume about that person? Assume they are innocent until proven guilty, right? So we have to assume they're innocent. We have to believe that's true. That's what the ho is. We have to believe it's true. Until what? We gather some evidence. Our evidence is a sample. Their evidence is blood and who knows what else, right? That's their evidence. The jury comes back. The jury says one of two things. Yes, what do they say? Guilty or do they ever say innocent? They say not guilty, right? You can't prove the ho is true. All you can do is say it's false or it's not false. I can't say it's true. We can't say they're innocent. I can't say ho is true. All I can say is it's false or it's not false. Okay with that? Keep that in perspective, okay? Consider a trial. What's the null hypothesis? Ho, the defendant is innocent. We have to assume they're innocent until they're proven guilty. And the ha is that they are guilty. They gather their evidence. We gather our sample. They come back and they say one of two things. They are guilty or not guilty. So I can prove that this is true. I can't prove that this is true. I can prove that this is false. I can prove this is false and this is true. If this is not true, I can't say that this is true. I know, that gets a little confusing for you guys. But they don't do it on court. They don't do it in law. We can't do it in statistics. And that's the trick. They're going to try to get you to believe. Just like a confidence interval when we say there's a 95% chance that the population's in there. No, it's either in there or it's not in there. I can't say that. To determine if the hypotheses are correct, the jury will listen to evidence. Only if there's evidence beyond a reasonable doubt Were we in favor of the null, or would the null hypothesis be rejected in favor of the alternative? So these are the decisions I want you guys to come up with. All right, if there's not convincing evidence, then they fail to reject it. We never end up determining if the null is true. Only there's not enough evidence to say it's false. In statistics, our evidence is our sample. We look at our samples and compare it to the population and measure that p-value. If there is a small p-value, right? That's normally we're looking at what? Less than 0.05, right? That's the value we typically look at. If that p-value is small, we are going to reject Ho. When that p-value, the probability of getting my sample, is small. And how small? Well, they're going to tell us in the problem. They're going to tell us in the problem. That comes up in just a little bit. But right now, I want you guys to know that when that p-value is small, we're going to reject Ho. Just wait. Just wait. When the p-value is small, that means we're really far away because the chances of getting our sample is really, really small. And we know we got a good sample because we know how to do all that stuff. So because I'm really far away, I can reject the claim. I can reject that Ho. It's false. When the p-value is low, the Ho must go. When the p is low, the Ho must go. You got to reject it. 05. 05. Good enough with that? Now again, sometimes it's different than 0.05. We'll talk about that in a second, but it's got to be pretty small. It's got to be pretty small. And if it's pretty small, I can reject the Ho. And if I reject the Ho, then what? I'm in favor of the Ha. I got enough evidence to say that Ha is true. If I reject the Ho, that must mean it's false. They're guilty. They are guilty. I can say the Ha is true. Okay? Now, I don't like this word because it says large p-value. And I don't mean large, but I don't mean really small. Y'all okay what I mean, right? I mean, 0.06 is pretty small, but in statistics, that's not small. Yes, ma'am. Wait just a second. Fair? Let me go over 2 more slides of something, and then maybe we can ask that question if you still have it. Okay. It's not always 0.05, right? So that comes up in the. So I don't like this large. Not small. How about that? When the p-value is not small, we're going to fail to reject. That's the terminology they want us to use. You fail to reject it. We can't reject it. We sure can't accept it, though. Don't accept no Ho. Don't. Bad doo-doos. Bad juju. Don't accept the Ho. Don't. It's words of wisdom. Sorry. Stop. I'm so immature. I should not be teaching this class. Good enough? Can't accept it. We're going to fail to reject it. I can't reject it. I can't reject it. I'm too close to that null. My sample is too close to it. I expect that sample to happen because of sampling variability. And if I expect that to happen, I can't reject it. I can't reject it. So I guess you could say that. We cannot reject it. We fail to reject it. You can't accept. We just can't reject it. We will not reject it. We fail to reject it. They like fail to reject. Don't abbreviate that. Don't FTR. You have to write fail to reject. That's the one thing you cannot abbreviate. Notes, homeworks, that's fine. That's fine. But tests, don't FTR it. You've got to fail to reject. Everybody okay with that terminology? Okay? Beautiful. So we got to have conditions. We got to have some calculations. And we got to have a conclusion. We got to have all that stuff. Well, that's my conclusion. The p-value, I'm going to compare that p-value. When it's small, we reject it. And if I reject it, I can say that we have enough evidence to say whatever we said, ha. If I reject it, it's false. I got enough evidence to say that ha is true. Okay? If it's not small, you got to fail to reject it. And if you fail to reject it, we can't say ha is true. Because basically we said ho is true, although we can't say ho is true. We just can't say that ha is true. Y'all okay? Sometimes students get that mixed up. I'm going to give you another little hint that won't hit me. Again, I'll give you some numbers. We're going to use math for that. We're going to use numbers. Yeah, it's kind of big picture again. I debate about showing this in a different order every year. These slides might be different than your notes. Okay, so let's fix that. How small does p have to be in order to reject it? Most of the time we look at 0.05. We're going to talk about this significance level. Significance level. And this is alpha. It's a lowercase Greek letter alpha. Start high, go low, make a little loop. Looks like a fish, looks like an X, looks like an A. I don't know what it looks like. I heard that students tell me it's fish. I don't know if it looks like a fish or not. You're not going to get graded on writing an A, but alpha, okay? That's the level we are comparing that p-value to. Okay, that's the value we're going to use as a boundary. Most of the time, alpha is 0.05. That's what we have used almost all year. Sometimes it's not. Sometimes it's 0.1. Sometimes it's 0.01. It could be any value. It will not be 0.3. Okay, 0.1 is typically the highest I have ever seen alpha. But alpha is that significance level. That's the value we're going to compare that to. That kind of answered the question earlier, Chloe, about that now? Okay, we're going to compare the p-value, the chances of getting, to the alpha value. We're going to compare those two. Most of the time, alpha is 0.05. Sometimes it won't matter what alpha is. Like your p-value might be 0.00003. Well, it won't matter what alpha is. You're going to reject it. Or your p-value might be 0.26. It really doesn't matter what alpha is. You're going to have to fail to reject it. It's just too big. Okay with all that stuff? Every once in a while, it might be something like 0.03. And 0.03, now we care what alpha is. Now we care what alpha is. So they're going to tell you what alpha is. They'll tell you what alpha is. If they don't tell you, then that means that you're going to use your knowledge of what alpha is and what does it tell us, and do I want to reject it or do I want to fail to reject it? Everybody okay with that value? Good? Alpha. So if the p-value is less than alpha, that's when you can reject it because it's small. If p is less than alpha, we'll reject it because it's small. If p is greater than alpha, then we fail to reject it because it's not small, it's big. Okay? So if it's less than alpha, we say it is statistically significant at that level, at the 5% level, at the 10% level, at the 1% level, whatever they give us. Typically, those are the three: 1, 0.5, 1. Those are typically the three values it is. I don't think very few times, if ever, are they different than those values. I don't think we're going to be much bigger than this. I don't think we'll be much smaller than this. Most of the time, it's one of those three. If they don't tell you, just use the 0.05. If they don't tell you, just use the 0.05. Typically, when they don't tell you, it doesn't matter. It's like it's going to be lower than all three of those, or it's going to be higher than all three of those. Any questions about that significance level? Okay, we're good on that now. That's what I mean. That's I normally try to tell you that first, but then sometimes I want you to know the p-value. It's just I don't know if there's a good way or better way or whatever. But we're there now, and that's all I care about. Okay, clicky click click. In the real world process, this was not has to do with AP. You should state the alpha value before you do the test. Don't do the test and then state the alpha value, because that's basically you're deciding what the answer is. Okay. Your conclusion has to have 3 parts to it. It's got to have 3 parts to it. I say it has 4 parts really, but 3 parts for sure. Okay. You got to compare the p-value to the alpha value. You got to compare it. Is it greater than or is it less than? What if it's equal? Do it again. Carry it out further decimals, because I've never seen it equal. Okay, it's either, it might be a little bit above or a little bit below, but I've never seen it equal. If it's equal, you can't reject it. I'll just say that. If it's equal to, you can't reject it. So we're going to compare it. Compare it. After you compare it, guys, you got to make a decision. Reject hoe or fail to reject hoe. If it's less than, you got to reject it. If it's greater than, you got to fail to reject it. You can only do one of those two. You can only do one of those two, depending on what the p-value is compared to the alpha value. And that's what's nice about AP statistics, because if you get the wrong p-value, but you make the right decision, they're going to give you the correct points. They're going to ding you for getting the wrong p-value, but they're going to give you the right points for making the right decision. Because you know the answer, you just got it wrong. You know the answer, you just got it wrong. Okay? That's that double ding thing. They don't double ding you. So compare the p-value to the alpha value. If it's small, you got to reject it. If it's not small, you got to fail to reject it. If you reject it, we got to give our conclusion. If you reject it, then you have enough evidence for ha. You have enough evidence for ha, because you rejected ho. If you reject ho, then ha's true. I can say ha is true. I have enough evidence to say that that water or that new irrigation system is not helping or hurting, is not changing. And if you can't reject it, you fail to reject it, then we don't have enough evidence for ha. So we have to make a decision, and we have to have a conclusion. We have to have a decision, and we have to have a conclusion. Again, I say there's 4 parts to this. They're going to grade 3. Depending on what this is, they're going to grade this one, and they're going to grade this, and then you better always do what? Put this stupid thing in context. Put it in context. You guys are doing a really good job about that stuff, because I've just beat it into your heads. When do I not do it? I don't know if I ever not do it. The question I graded last year, as long as you did it 1 part, either A part, B part, or C part, they gave you context. They're kind of being, I don't say a little bit lenient on context, but you got to get it in there, but they don't really care where you get it in there. We're going to have it 2 or 3 times, right? Because you're going to define what the P is, and then you're going to have it in the context in the answer. You're probably going to have it a couple times. Better to have it a couple times than no times. Okay with all that stuff? Let me give you one more hint. This is the hint that I gave about 3 years ago. Oh, this is what I say. This is my conclusion. Again, some do it bullet points. Some write it out in sentences. So I don't care. You just got to get those 3 things in there. Since P is alpha, P is less than alpha, P is greater than alpha. One of those 2, right? Since P is less than alpha or greater than alpha. One of those 2 things. That's what I'm going to say. Since this happened. Okay? Now, depending on what that is, I'm going to say we reject or fail to reject. Right? If it's less than, we reject it. If it's greater than, we fail to reject. If it's less than, we reject. If it's greater than, we fail to reject. And then ho. And I actually don't have to put ho in context. You don't have to put ho in context. You can just say, I'm going to reject ho. If you want to put it in context, you can. Don't have to. And then I'm going to say, we have enough evidence or we don't have enough evidence. And if we rejected, we have enough evidence. If we don't reject, we don't have enough evidence. If we fail to reject, we don't. If we reject it, we do. To suggest, and then I'm going to be context. I'm going to be context. That's how I'm going to write my conclusion. Just like I wrote, we are 95% confident that the interval from here to here captures the true, right? 28 of you cats in here, you don't have to write it the same way as I do. You don't have to write this the same way I do. You just got to get it all in there. Compare P to alpha, reject or fail to reject. There is or is not enough context. I try to make it 3 things so that you have the rules of 3. I end up with rules of 3 because I put the P greater than or less than alpha in another place so that it has 3. They don't care where you do it all, you just got to get it in there. Yes, no, maybe, y'all okay? Hopefully it makes sense to you, but I know it's the first time you guys have seen it, and when you get a test in front of you, you won't believe how many times I read, since P is less than alpha, we reject, there is enough evidence. No, there's not enough. You rejected it. There's not. There is. Oh, I get confused. Y'all okay, right? I get confused on the test, and I get it. I get it. Don't add things that can't. If you reject, if it's less, you have to reject. You don't have a choice. You have to reject. And if you reject it, you got enough evidence. If it's greater than, you have to fail to reject. That's the one kid that I had that I told you a couple times that his calculator died on him on test day. Calculator died on him test day. He made up a p-value. He knew the z-score. He knew about what the z-score was. So he said the z-score looks to be somewhere around 2 something. I don't know, I'm making all that part up. So the p-value is pretty small. And because the p-value is pretty small, I'm going to reject it. And I said he ended up with a 5. Didn't have to do any of the calculations. He was smart enough to know about how far it was going to be. Like I said, he wasn't a dumb guy. He just calculated that. This is my hints to you guys. This I don't know, about 6-7 years ago, right? This is greater than. That's greater, right? P is greater than alpha. Greater. G-R-E-A-T-E-R. 7 letters, huh? G-R-E-A-T-E-R. 7. That looks like a 7. If you don't know that that's the greater than symbol, that's the greater than one. It looks like a 7. The less than looks like an L. Huh? Greater, you fail to reject. There is not enough evidence. That's a bigger word, that's a bigger word, that's a bigger word. And what I mean by that, it's bigger than if I put less. Because less is smaller than greater. And if less is smaller than greater, I have to reject. Because reject is smaller than fail to reject. And if you reject, there is enough evidence for ha. The smaller words go together, the bigger words go together. And if you can kind of keep that in the mind of you when you're writing these things down, that will help you a little bit. Good enough? If P is less or greater than alpha, if it's greater than alpha, you can fail to reject Ho. There is not enough evidence for Ha. If P is less than alpha, you can reject Ho. And if you reject Ho, there is enough evidence for Ha. Context. Yes, no, maybe? Boom. 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 I get scared because I'm going to hit somebody in the eye. Boom. So I'm aiming low. Wound you. I can't say that. Great question here. If you understand this, you're pretty much good for today. A company has developed a new AAA battery that's supposed to last longer than the old AAA battery. However, these new batteries cost more. So the company would like to be convinced, do they really last longer? Based on years of experience, the company knows that the regular AAA battery lasts for 30 hours. There's the Ho. Mu, because it's means, equals 30. I'm trying to prove that the new one's greater than 30. The company selects an SRS of 15 deluxe AAA batteries, uses them continuously until they're completely drained. The sample is 33.93. Does it look like they last longer? Yeah, I got a little evidence. I got something showing me that looks like it. I don't know if I have statistical yet. Where mu is the true mean lifetime of the deluxe AAA batteries, the resulting p-value is 0.07. Woo! That's pretty small. However, they told me alpha is 0.05. What conclusion do you make? Since p value, and you might put 0.0, what was it, 7, is greater than alpha, 0.05. They like for you to do this with mathematics just to make sure, because there will be somebody out of 108 kids that think that 0.07 is less than 0.05. Somebody will think that. It's not, but somebody will mess up because you just get pressure and you get into a rush and you just don't think sometimes. And it's okay, I get it. But since we're greater than 0.05, we fail to reject Ho. Beautiful. I'm going to get points just for that. Get some points just for that. I'm not going to get all, probably get a P. I'm not getting an E. Fail to reject Ho. If I fail to reject, there is not enough evidence to suggest the new battery mean, I don't know, lifetime, I don't know where we're starting to go with all this stuff, is greater than 30. I don't know. I'd like to talk about mean somewhere in there. I'd like to talk about the population in there. I don't want to emphasize the sample. Don't mess up. Let's see what they said. Because 0.07 is greater than 0.05, we fail to reject Ho. We don't have convincing evidence that the true mean, that's nice, right? The population, the true mean lifetime of the company's AAA battery is greater than 30. Good enough. Good enough. I don't mention 33 in there anywhere. I don't mention that anywhere. If you wanted to, I guess you go, even though my sample was 33, I still don't have convincing evidence because 33 is not far enough away from 30, which is the true mean. I don't know. Right? You can start writing a novel on this stuff. We don't want to do that. Yes, no, maybe. Y'all okay? Please, 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 please don't ever accept ho. It's illegal. Sorry. Type 1, type 2 errors, I'm not talking about. I have learned my lesson. There is no way that you guys can handle all what I've gone through today, much less type 1 and type 2 errors. So that's why I have 2 review days built up, because we're going to do 9.1. Tomorrow we're going to do 9.2. We're not going to do errors on 9.2. We might do errors on 9.3. I don't know. But if we don't do errors on 9.3, we're going to do it on review day 1. And then we got review day 2, and then we got test. And depending on what the heck happens with this apocalypse, we have to adjust some things. Keep in mind, they don't move the AP test date. Keep in mind, they don't move that date. So we have some wiggle room, and I want you guys to enjoy stuff if we don't have it. But just understand that I do owe it to you to get to a certain point at a certain time. Okay with all that stuff? Good? So keep your little computer. I mean, I'll see y'all tomorrow, but keep your computers, and I may send you something, and it's going to be too cold to go out there and stay for very long anyway, so you're going to be bored, and you're going to run out of TikToks to watch. So watch me. Y'all good enough with all that stuff? Your assignment's posted for 9.1. It should be posted for 9.1. Oh, I'm supposed to emphasize, tell them what you taught them, right? I hope you can state the appropriate hypotheses and knowing the alternative, interpret the p-value in context, make an appropriate conclusion, and then interpret type 1 and type 2 errors, which you can't do yet. I told yesterday's group that if you see a question with type 1 or type 2 errors or anything about errors, let me know. I'm going to move it out. I think I removed them all. Right? It had more questions in there. I removed those cats, so you shouldn't have anything. Okay? Shouldn't. It might be in there.